Good morning. Welcome to Computer Lab Space. Watch my previous videos for problems on increment and decrement operators. Okay. Today we will solve few more examples on combination of different operators. So this is what the precedence and associativity of different operators I have explained in my previous videos. So whenever it is necessary to solve the problems, I will come to this slide. Okay. Let's start now. First, I will take one simple example problem on wait, I'll show you. On assignment operators. We already know, right? What do you mean by assignment operators? As well as how we are going to write the shorthand assignment. So for example, if this is an assignment operator like A is equal to A plus 5, or even it can be A plus B also. So this is what the expansion of a shorthand assignment. So let me show you how to write the shorthand assignment for this. So A plus is equal to 5. So this can also be written in this form. So this is what we are going to call it as a shorthand assignment operator. So we'll take some examples on this. So A plus equals B into equals C minus equals 5. Okay. So since it is an assignment operator, how we are going to solve? Or let me take C. If you look at this, where is our assignment operator? Here it is. So the associativity is from right to left. Clear? So now we will solve the problem. We need to take some values even for A, B and C, right? So let me take A equals 3, B equals 5 and C equals 8. Okay. So now let us solve. Since it is having the right to left associativity, we are going to solve it from right to left. So first, which one we are going to solve? C, right? So if you want, you can also make use of the brackets so that it will be easy for you to divide this. Or else you can also separate it like C minus is equal to 5. So this one you are going to solve first. The remaining you are going to write like that only, just as it is. Okay, so C is equal to C minus 5. Right? So this one you need to solve first. So A plus equals B into, yes, C is equal to C minus 5. What is the C value we are having? That is 8. So 8 minus 5, what you are left with? B into is equals C is equals 3, right? So this is already solved now. So next we need to solve this one. So this expression. So how we are going to solve this? A plus is equals B into, this is in the form of equals C equals 3. Right, so this whole you are going to consider, this whole you are going to consider as C value, and this you can also write it as 3, isn't it? Now you need to solve this expression. So A plus equals, this you can also write it as, this is already in the form of a shorthand assignment operator, right? So now you need to expand that. How we are going to expand? B equals B into 3, isn't it? So now rewrite this. B equals B. What is the value of B here? We have taken 5. So 5 into 3. So A plus equals B equals 5 3s are. So you're going to write it as 15. Now this is in the form of a shorthand assignment operator completely. So this you can write it as A equals A plus, in place of B, the recently updated value is 15. So A plus 15. What is the value of A we have taken? It is 3. So 3 plus 15 equals 18. So this is what the final answer for the assignment, for this expression which is on assignment, that is a shorthand assignment operator. Is it clear? We need to solve it. The associativity of this expression is right to left. Why? By looking at the precedence and associativity table, you can easily find out for the assignment operator, we have right to left associativity. Is it clear? Any doubt in this? If you have any doubt, you can put in a comment section. Okay. So next, we will solve the next problem, which is a simple problem on modulus operator. Okay. So let me take j equals 4 and k equals 2, and the expression goes like this: plus k mod minus j. Is it fine? Now, since both are independent, k value is different and j value is different, we can say it is a independent, so you can solve it individually. It is a pre-increment and pre-decrement. We can solve it by right to left. You can choose the associativity first. Why? Because since both are pre-increment and pre-decrement, we need to solve it by right to left. Is it clear? Now, since both are independent, it's okay, you can solve. But when there is dependency, like a single variable is there, for example, instead of j here, it may be k. So at that time, you need to solve it according to the associativity only. Okay. So since it is a pre-decrement, minus 4. So 4 value, j equals 4, and this 4 value is going to be decremented by 1, and the value you are going to get is 3. Then k value, it is increment, so k equals 2, and since it is a pre-increment operator, you're going to increase by 1, that is 3. So 3 mod 3 you are going to get. So while making use of a modulus, 3 ones are 3, and the remainder is 0. For modulus, you need to consider the remainder, and for division, you need to consider the uh, what is that, quotient, right? And 3 mod 3, the value will be equals 0. What is the updated j value and k value? J is equals 3 and k equals 3. So this is how you need to solve the problem. So we'll go for the next problem. Yes, I will solve one more example problem, which is a simple one, but it is a combination of a modulus and relational operator and arithmetic operator as well. So let us take 100 mod 20 less than equals 20 minus 5. Okay. First, you look at the table first and go through what is the associativity of this. Which one is having the highest priority? The modulus is having the highest priority compared to all other. We have modulus, then less than equal to, and minus in the expression whatever I have taken just now, right? So you are going to decide what is the priority first. Since the modulus is having the first priority and the associativity is from left to right, you need to solve the expression from left to right, and the first priority you need to give for the modulus operator. Then choose the second priority you need to give. Then we have the for the arithmetic operator, it is plus minus. So first priority you need to give for the modulus, next priority you need to give for the 20 minus 5 in the expression, then you need to give the next priority for the relational operator, that is less than equals. Here you can find less than equal, and all three are having the left to right priority only, and that doesn't make any difference also. So we will go and solve. So according to our precedence and associativity operator, this is having the first priority, right? Okay. 100 more 20. As I already explained, 20, 100. So 25 is a 100. The remainder is 0, and you need to consider for this, right? For modulus, you need to consider the remainder. So rewrite the expression: 0 less than equals 20 minus 5. Which one you need to solve first? You need to give the next priority for the arithmetic operator. So this is having the second priority. So 20 minus 5, you can write it as 15. And now the last priority is for the lesser than and equals. So 0 is lesser than equals 15. Yes, the condition is true. So we already know when we are working with the relational operators, you are going to get the Boolean value as the result, either 0 or 1. That means if it is lesser than equal to, you are going to display the value as true. True means 1. And the false, if it is false, you are going to display the value. The result is 0, right? So 0 less than 15, the condition is true here. So what is the outcome of this? It is 1. Is it clear? So this is how you need to solve the expression. Fastly we will go for the next problem. I think this requires a little bit more space. So I will go for the next empty slide. We'll solve here. 100 mod 20 less than equals 20 minus 5. One more thing you keep in mind, whenever they have given some long expression like this in exam or in your internal, copy the problem properly. Okay, somewhere few students will miss out minus 5 or 20 or the symbol, the operator, something they are going to do mistake in that. So they will lose marks. So to avoid that, just cross check the problem once, sorry, twice or thrice before solving the expression. Is it clear? Plus 100 mod 10 minus 20 equals 5 greater than equals 1 not equals 20. So I'm also cross checking the expression. 100 mod 20 less than equals 20 minus 5 plus 100 mod 10 minus 20 equals 5 greater than equals 1 mod, sorry, 1 not equals 20. So for this, first priority, by looking at all these operators, you will come to know that you need to give the first priority for the modulus. Since this expression, we are going to solve it by left to right, because nowhere we are going to get with what is that? Right to left. Moreover, since the first priority we are going to give for the modulus, we need to solve it by left to right. So we are solving this left to right associativity. Clear? So 100 mod 20 we have already solved in the previous example, right? So the remainder we are going to take it as 0. 0 less than equals 20 minus 5. Since even the steps carries marks if your answer goes wrong, or somewhere if you have done any mistake, even the steps carries marks, right? So better I suggest you to solve it step by step, even if takes little bit more time. Okay, in this case you can solve it directly this one, right? It's the second priority. We're having the second priority for this. So 0 less than equals 20 minus 5 plus 100 mod 10, obviously completely divisible, and you're going to get the value as 0. Minus 20 equals 5 greater than equals 1 not equals 20. Now additive, like minus or plus, will be having the next priority. So I'm just going to solve this. So 0 less than equals 20 minus 5, 15. Then you can solve it directly here. Plus 0 we have, then minus 20 we have. So 0 minus 20, or yes, 0 minus 20, or however you are going to do, you are going to get it as minus 20 only. So equals 5 greater than equals 1 mod 1 hot equals 20, right? So next you are going to solve this, the fourth priority you are going to give. Either you can make use of like this also. I'm going to give 4 and make it 5 if you want. So 0 less than equals 15 minus 20. So it is minus 5 equals 5, then greater than equals 1 not equals 20. Now, if you look at this expression, we have the relational operator, then assignment operator, that is sorry, this is also relational operator, and this is also relational operator, and this is also relational operator. So you are going to solve it by just check the precedence if you want to know. So relational operators we are having from left to right only. So even this you are going to solve it by left to right. So 0 less than equals minus 5. 0 less than equals minus 5. No, the condition is false here. Minus 5 is lesser than 6. So you're going to give the false as 0. Equals 5 greater than equals 1 not equals 20. So here you can give the next priority for this one 5 greater than equals 1, right? So this is having the next priority. So 0 equals 5 greater than equal to 1. Yes, the condition is true. So 1 not equals 20. So if you look at this, sorry, equality. Sorry for the previous one. See, relational operator includes only less than equals, greater than equals. So this is having the priority. And to next to this we are having equality priority. So equality, that is equals and not equals. So now we need to give the next priority for equals and not equals, and the associativity is from left to right only. So 0 equals 1. No, the condition is false here, right? So 0 not equals 20. 0 not equal to 20. The condition is true here and the result is 1. Is it clear? So this is how we need to solve the expression, and I will come up with more sample examples in my next video, and hope probably I will stop to there for the sample examples. And if you have any doubt in any of the expression, or if you want to solve me few such examples, you can kindly comment in the comment section so that I will make a separate video on that. Thanks for watching this video, and hope this video is helpful to solve the problems on the operators. And if you like the video, click on the thumbs up, subscribe, and click on bell icon for the notifications. Thank you.